It starts around identifying some kind of an overarching problem that you can anchor a part or all your course, depending on how you want to framework. It can be as big or small as you want it to be. Set up that problem and start your material or teaching on your first day of class, in fact, with that. And then you use that to probe into, and this is not part of the formalized legacy cycle, which is probe into prior knowledge, seeing what do they know that they think is relevant, what do they think they know that might be relevant that they need a refresher on, and what do they think they might know that they might need to learn that they don't know that is relevant to that problem or the challenge that you give them. You then take them around to hear what experts have to say about that challenge and the problem, what's important, what's not, what do you need to consider. Then you go through the key or the crux of the whole legacy cycle, which is the research and revise phase. This is where you can do whatever you want with it. You split up your grand challenge into a bunch of smaller questions or problems, and you then each of them you go through, you cycle through what it means, what's relevant in there, and you learn the things that you need to in the context of answering that question. And build on that to subsequent questions till you start to see the picture that will help address the grand challenge. Beyond that, then the rest of the cycle is test your mettle. So you push yourself or the student to applying this to other contexts, other problems, and then you can complete that cycle again if you want to go back to a newer challenge, or just go public, which is sort of display or disseminate what you've learned in the context of the classroom or beyond. So that's something that made sense to me. Because suddenly I could see, as I started off saying, context seemed to be so important to the student. So we developed this challenge. It's based on a birthmark, a congenital birthmark called port wine stain. It's essentially a bright red birthmark, often seen in the face. And so that's what makes it over time, it can get worse. But typically it's the psychological factor because it's a huge discoloration of the face seen at birth. So what I do is I use a picture of a 3-month-old baby who has a huge birthmark starting from here all the way to the shoulder, and talk about the fact that, give context, the baby is your niece or your nephew or something along those lines. So there's a personal sense in it. And the member of the parent of the baby, so a sibling or a cousin, comes to you saying, the doctor says lasers are the best way to treat this condition. And comes to you as a budding biomedical engineer. What do you think? Should I do this? So now, you force them to think about, okay, what do they know as biomedical engineers coming into my classroom that might help answer this question for their sister or brother, let's just say. And so we start off by probing that knowledge on the very first day of class. This is the very, very first day of class. And ask them, okay, what do you know that you think might be relevant? And then we talk about, so they start saying things like they tend to concentrate more on the biology of the problem. You want to make sure that there's no scar tissue formed and that the cost is effective. And how many times would they have to have this treatment? And what would be the long-term effects of this? So they tend to focus on those aspects of it. Then you start to go towards the next level and ask them, what do you think you need to know to be able to answer this more thoroughly? That's when you start getting, I need to know what laser they want to use. And they don't know the terms. What intensity of laser, which is not the right term, but that's what they know. What intensity of laser do you need? What color of laser do you need? What type of laser? So they start coming up now with the kinds of questions that I'm interested in, which is exactly what you want. They talk about the wavelength of the laser, the frequency, power, and so on. They come up with those terms. So that jumps right into, you say, okay, that means you need to first know what's a laser. So now I can talk about what's a laser, talk through all the different ways of using a laser. And at the end of that unit or part of things, that's the first phase of the research and revise question. Say, okay, are you ready to answer the question of what laser do we need? And they'll think about it and they go, no, not really, because we still need to know what in skin absorbs or not. Exactly. So now let's talk about absorption and what all can happen when that light goes into the tissue. That's the next level of questions. And so on that we go through, so we tease out exactly what is needed to learn. And so now they have context to when I give them a model, a sort of a different partial differential equation, they're no longer intimidated because they know that that equation is being used for something practical. So one of the first phrases I learned from the Center for Teaching is think, pair, share, right? And I use that in different ways, but often I'll give them things to go off and find out, go research on their own, and then pair up or group up in 2s and 3s, and then they can decide between them if they all agree. They just feel more confident in talking in the classroom when I do that. And then our discussion will flow into the whole classroom. So in my individual sub-challenges, as I like to call them, in their research phase, I do these in different ways and depending on the topic. Interesting is that somehow for things like modeling and simulation, students just seem to do better. Better is a very ambiguous term, but still just get their hands around it a little bit better when they work with somebody else. So I'll pair them up and give them some more general parameters as well as specific. Tell them go find out what are typical values for skin and go apply it to the model. But usually when I make that, it's given as a homework problem, but I'd make it due like a week. So I have 3 class sessions between the time I've assigned it to the time it's due. And we'll talk about it at every class period as a group. So that I tell them, don't wait till the night before it's due because that's not going to work. So usually most students have thought about it, but even if they haven't, there's always a few who have. So we'll talk about it in the class, right? So we'll say, okay, what did you find when you just did zero absorption and only scattering? And they'll tell me something. It's all over the place. I couldn't really see a trend. Somebody else will go, yeah, but when I increased the number of photons, it did make sense. So, oh, that's what so they are talking it out amongst them as to what they need to do in order to get to the point where the real analysis I want to do, which is what happens in skin. Originally, I used to not do that. You assign a problem and you go, let me keep going. They can just turn in it at the end of the week. What I would find is some students would give me this noisy results that has no meaning, but they don't know how to solve it. They didn't bother asking, and they didn't get anything out of it. But I realized that I needed some more feedback cycles, if you will, in order for them to know what I'm trying to have them achieve and understand with this whole modeling exercise, that you need to have statistically lots of photons before you can get a non-noisy, nice, smooth curve where you can actually see where that light goes. And as well as how deep do you need to get to, and therefore what kind of photon do you need, and so on. And so that's why I realized that feedback is an important part, because it's easy to give them a problem. I call them mini challenges. To give them a mini challenge and have them articulate it and then continue on with their work and not come back to it. It's sort of more time efficient, certainly, as a teacher to do that way, but it's meaningless. Then you might as well not have given them that mini challenge. Maybe it helped 10%, but it's not worth it. It really does help if I can come back to it and say, okay, now we've talked about this. Now go back and answer that question again, knowing what you do. What did you find? Asking that question at the end, what did you find? What did you think? Seems to be really relevant and important to the learning process, and critical, I think, to their learning. I've just found the biggest aha moment for me in this whole process that made me think this is a valid approach was often when I would walk into the classroom, students are already talking about what we're going to talk about in the classroom. They're already talking about port wine stain and lasers and, what it can be used for. And somebody else is talking about, oh, my friend has a tattoo and he's talking about removing it. I wonder if what we learned in the classroom can be used for that. Instead of talking about what was on YouTube or what was on Facebook that, they saw, they're talking about something that's relevant to the classroom. That's when I know I'm doing the right thing. So now I use this approach pretty much to all my classes at different levels, whether it's a really small concept or a whole class, because I found it to be invaluable to my teaching.